Okay, now we're going to move on to doing qualitative analysis of the cations. And here we have ammonium hydroxide. I've poured some ammonium hydroxide into here to test for ammonium NH4 cations. We warm it gently and test for ammonia gas with damp red litmus paper. And if ammonia gas is produced on warming, it should turn the litmus paper blue. And there we see already the litmus paper is starting to turn from pink to blue as ammonia gas is produced. So that's a positive test for ammonium ions in this liquid. Okay, so we're going to move on to qualitative analysis of the cations. And for the cations, we do two tests. We test them first with sodium hydroxide, and then we test with ammonium hydroxide. So we've got the 5 cations that we're going to be testing here. We start with calcium, then we're going to test copper, iron 2, iron 3, and then zinc. We'll take a test tube and we're going to add a small amount of calcium chloride to each of 2, this is any salt of calcium, each of 2 test tubes. I'm putting it in 2 test tubes because I'm going to do both tests at once so we can look at the results and compare them. Each of these I'm going to add dilute sodium hydroxide to one and dilute ammonium hydroxide to the other. So for calcium, we are going to see, hopefully going to see a precipitate, a white precipitate. This is, we're using, first I'm going to add, let me put this one down. First I'm going to add the sodium hydroxide. And there we see a white precipitate. If I keep adding sodium hydroxide, so I added in excess, you will see that this precipitate is insoluble in excess. So the precipitate remains even when I've added more sodium hydroxide. That's calcium ions, so calcium hydroxide is being formed. The ammonium hydroxide, we're expecting to see either no precipitate or a very slight white precipitate. So I've made a black background here so that we can look really carefully for a slight, and I'm hoping you can see that there's a very slight white precipitate that forms with ammonium hydroxide. So those are the tests for calcium cations. Okay, next we're going to do the tests for copper ions. We've got copper nitrate. Copper, as I said before, is a transition element, transition metal, and transition metals often form colored compounds. So a nice bright blue copper nitrate. I'm going to add a little bit, 3 cubic centimeters to 2 test tubes. I'm going to test first with sodium hydroxide and then with ammonium hydroxide. So we watch carefully. With sodium hydroxide, form a light blue precipitate. And I don't know if you can see, it's quite a gelatinous precipitate. It's like jelly-like in texture. And if we keep adding more in excess, we find this one again is insoluble in excess. The precipitate does not dissolve when I've added excess sodium hydroxide. Okay, if we add ammonium hydroxide to copper ions, you see that we form a light blue precipitate. Okay, and again, it's quite gelatinous. If I keep adding ammonium hydroxide, this precipitate will dissolve, leaving a dark blue solution. So let's just mix it up a bit. I'm going to add excess ammonium hydroxide, and we should start to see that precipitate dissolve and form a dark blue solution. The bottom you can see some precipitate still there, but at the top where it's all mixed nicely, it's dissolved, and that is a positive test for copper ions. copper with sodium hydroxide, copper with ammonium hydroxide. In this one, we've got iron 2 sulfate, so we've got iron Fe2 plus ions. We're going to add sodium hydroxide to the first test tube, and what we see is a very dark green gelatinous precipitate. And if you're able to see carefully at the bottom, maybe you can see the green color nearer the bottom. It probably almost looks black. It's like a licorice green. That's with sodium hydroxide and with ammonium hydroxide. Again, we see a green gelatinous precipitate. Both of these are insoluble in excess. If we keep adding ammonium hydroxide, the precipitate does not dissolve. Next, we're going to move on to iron 3, and we can see it's iron 3 from the formula, FeNO3 3, which tells us it's Fe3 plus ions. Again, we're going to mix. We're going to add 3 cubic centimeters to each test tube. We're going to add sodium hydroxide to our first sample and ammonium hydroxide to the second. With sodium hydroxide, we see a red-brown precipitate. If we add an excess sodium hydroxide, we should find that the precipitate is insoluble. It does not dissolve, it remains solid. And with ammonium hydroxide, again, we see a red-brown precipitate, jelly-like precipitate. If we add an excess of ammonium hydroxide, the precipitate does not dissolve, insoluble in excess. The last cation that we have is zinc. We're going to put some zinc in each of these, zinc nitrate, in each of these 2 test tubes. With zinc again, we are expecting a white precipitate. So first we're going to test with sodium hydroxide. And we find there is a white gelatinous precipitate that is produced. And if I keep adding sodium hydroxide, if I add a whole lot of sodium hydroxide, we can see that this precipitate is soluble in excess. The precipitate is dissolving as we add more sodium hydroxide. Let's just add a little bit more to dissolve the precipitate at the top. And eventually we'll end up with a colorless solution. We've dissolved that precipitate, zinc hydroxide. Zinc with ammonium hydroxide now. Again, a white precipitate is formed, and if we keep adding ammonium hydroxide, we should find that in excess the precipitate will start to dissolve. Running out of space to add more ammonium hydroxide. At the top you can see that in excess the precipitate begins to dissolve. A little bit more. Soluble in excess.